Hello, and thank you for coming to watch my video. I do appreciate it. The aim of this video is for me to put together like a mini Python project, or let's just say DevOps project, where I aim to do a few things. So one of them being create a very basic application, which you can see on my screen at the minute, and get the application to run locally. And then what we can do along the journey is we can package the application in Docker, and then check the application into Git as well. And then hopefully from that point we can go on create an EC2 instance on AWS. So spin up the server, configure it with tools, infrastructure as code tools such as Terraform, and also Ansible as well will be used. And the aim or the end goal is to provision application into EC2 and then get it to run on that server basically. So in a nutshell, this is my application. Like I've just said, it's a very basic application. So in here, what we're trying to do is we're trying to initiate our application itself, and all it's going to do is it's going to return with a very simple message: hello from EC2. I may change this message, but in a nutshell, that's all it's trying to do. Run the application, and then the request, and then the return is a message that gets delivered to say hello from EC2. So this is our application file itself, and we've also got a Docker file as well with some configurations, such as installing pip and then the requirements .text file, which is also here as well. Now, in that requirement file is a Flask, simply because our application does use, it's a Flask application, basically. So if we proceed and run application, so this is in its, completed form. So if we do right click and run application, we can see it kickstarts the server, and it gives us our address here, or our endpoint, using the 5000 port. So if you click on that port, and like I said before, we run the application and it returns with hello from EC2, just like this. So yes, at this point in time, we could create a Docker image, and that will be the image we created, and it is copy of our application. We can run it in any environment, and it should run as it's done locally for us to see it up until this point. So just to interject here again, I hope this video does help someone, especially if you're new into a DevOps journey. If you're starting from the very beginning, and also maybe you might be a senior, experienced DevOps engineer as well. You may find one or two things useful that you don't do in your normal day-to-day practice. And also, as usual, I am very open and welcome to any feedback, whether good or bad. It's all a learning process for me as well. So yeah, if we proceed, let us build our Docker image. So one of the pre-requirements is to have Docker running. So if we open Docker, okay, so our Docker is running, as you can see on here. Engine is running. We've got a few images on here which are enabled or are up and running as well, and then we've got our containers as well. So if we come back out of this one, and in a clean terminal, if we run this command here, so docker build -t, and our name that we can give our application. So if we do simple app and then hit enter, so what this should do is this should build a Docker image, which is a version image of our application in a nutshell. So as you can see, that should be complete. That is indeed completed. We can also verify this by running the Docker application itself to yeah to basically running the Docker container, which our application sits in. So if we do Docker run minus hyphen b hyphen p, and then the port, which if you remember it was 5,000, and then the name that we give application, which is simple app. So if we do enter here, we get some error. Okay, so it looks like most likely the port is being used. So if we change the port to 5001, and hopefully um, that should be accepted. Yes, so that we can see it is running. So the container should be built for us at the minute. So if we go into our Docker application itself and see if we can find it here, which is here, simple app in a nutshell. So happy with that, we can proceed to the next step. So the next step in our journey is to do the version control. So in here we can use Git to assist us, and we will application to Git, and then take it from there. To get started with the Git, if we a new terminal, a fresh clean one, and initialize Git by running the command git init. See on here we have an empty repository. So if we move on to the next step by adding git add, so again we can see thing has been added as of yet to our command. Our files has been added as of now. So we need to look into committing some of our work. So if we do git commit and hyphen, and give it some comments as to what we're trying to do. So if we do initial commit, that should be okay, and then we hit run. So what should happen here is it should commit everything we have in our project thus far. At this point, I've paused the video, I've gone away onto Git, and I've created the repository for our application, which is here. So if we come back in our terminal and then basically link the Git setup we've done locally, link it to the one we've created on the remote URL. So then if we do git remote and we add in origin, and we do maybe HTTPS, I think the easiest thing to do will be to copy that in here. Okay, and then that should be accepted, that should be linked. So now that they're linked, I think the next thing we should do is just to push our application basically. So if we do git push -u, and then if we do origin main, and then we see that error, we failed to push. So if we look into the error further, it looks like there is no such, it's not found a match. So this will be an issue with my command. We've got git origin main, and what we could do is run git branch, the branch that we're currently on, which is master. So then if we go back and change main to master, hopefully that should be accepted. Yes, and as you can see on here, it has done, it's basically pushed our code or our application onto the repository which we have created in here. And at this stage, we can simply verify by going on to the remote side of things. And you can see in here, it says the master has just had it's had recent pushes 2 seconds ago. So if we refresh screen, you should see the initial commit which we saw before, and then you can also see some information regarding our application on there as well. Okay, so I think so far so good. What we've basically done up until this point is we had the initial setup already, so the application was already set up as at the time the video started. And what we've done is we've gone on since then, we can rerun it, and the application was running fine. And we went ahead to create a Docker image to store an image of our application. And then what we've done since then is we've checked it. We've configured Git with our Git account, created a repository, and we've checked out. We've committed our changes, our application, and pushed it to the repository. So that's there so far. We'll move on to the next stage. So the next step is to configure AWS, our instance server. Now, the easy way would be to come on, set up my AWS account, come online, and manually launch the instance by configuring the details on the UI front. However, we could use an AIC tool. So AIC for anyone guessing, or if you don't know, infrastructure as code. So this is a practice whereby rather than configuring everything at the front end, we can basically use a series of commands, and that can provision things for us. So it can go away, create our infrastructure for us. It can also configure a few things for us as well. So having mentioned this, I've tried to launch an instance manually, and that's only so I can grab one or two key informations on here. So if we skim through this, my AWS Linux is what I'm looking for, the type of image I'm looking for. So the AMI is the free tier eligible as well. Now we need to make reference of this AMI ID that will be useful for our configuration. And then if we progress through, the instance type is T2 micro. I've also added a key pair as well. So I've created a new key pair and stored it on my local machine. So I think pretty much in a nutshell, that's all the information we need at this point. If we then go to my local machine, okay, so if we revert back to the PowerShell, we do have Terraform configured. So if I do Terraform -v, which stands for version, spell that incorrectly. So if I correct that here, so Terraform -version, you can see on here that I've got a version there. So it's clearly installed on my machine. So if I clear that now, I've created a folder, which is basically my project folder. Now I've labeled it my Terraform practice project, and in there is my first file, my Terraform file, which I'm going to use. And within this file sits all the configuration we need to create our instance. So if I come on here, let's change directory and access that folder behind, which is there. So as you can see, that worked. We are in that folder now. So whilst in there, just to confirm, we can just run a list. So ls command that returns with any information that's in here. So as we saw before, the main file, so main.tf Terraform, is in there. So what we can do is we can, view what's on the file. So view only. So if we do run the cat command, and we do main.tf, hit enter. Now we can see our Terraform file. So without going through it in detail, if we just skim through it, what we're looking for here. So the very beginning is the provider config. So that's AWS as a provider, service provider, and then the region being EU Central 1, which is just a region I've selected. So Europe Frankfurt. If we go down here, that's EU Central 1, and going back into here, if we scroll through further, we've got some gateways, so internet gateways, subnets, and these are all information I've captured on the main screen as you attempt to create it manually. So if we scroll through further again, I've got my, so there's further more details on the gateway. If we scroll through further, so this is a security group that allows SSH security connection or secure connection. It also has details for Jenkins. So Jenkins will come later on in the video. So there's pods configurable that allows Jenkins access to our instance. So further down the form, down the document, we come across this AIM role with instance setup, so EC2 instance setup as well. So as you can see, we've got few details that have been captured here. If we then scroll down even more, we've got, if we go to the instance setup, so in here we have the AMI I mentioned moments ago, so which is this here, so corresponds. And the T2 micro, as I also mentioned, and that is here, that's the instance type. Terraform practice projects, that will be our key pair, as you can see on here. Then the rest is additional relevant information that's needed as well. So there's also, as you can see on here, with at some point, once the .tf file, the Terraform file goes on there, it's to perform a few actions as well. So one of them being, installing Docker, enabling Docker, starting Docker, that sort of thing. Nginx as well. In another one, which hopefully we can cover as we proceed in this journey. And then in the end, we've got some few outputs here, which is just the public IP address as well. So having gone through that file, we've not actually opened it to edit it. We just view only. So we can initiate by running Terraform init. Hopefully that is accepted, and it should do its magic. As you can see, it did install a few things. So HashiCorp being one of them, and a few other good, required basically configurations really. So as that's worked, what we can do is we can come in here, Terraform plan, and let's see what comes back. Okay, so it looks like the apply has also been accepted. So if we go through what has been done, I think it's gone through the file itself, and it highlights what's going to be applied, and also what tasks are going to be carried, just like we went through the file in each step. So as you can see, everything is in the green. which is good news. It means basically we are allowed to proceed. It says on here, all the above actions which we've just gone through at a speedy rate. Do you want to perform these actions basically? And what we can do is we can select a yes, and then it will go on and run the actions. So as you can see, it's creating the EC2 and basically everything that we've discussed so far. Okay, so the apply has gone processed and gone through well. As you can see, there were a few things being done here. One or two may be replaced. If we skim through, it goes to show the green areas are data that will be applied, and the red will be either unchanged or removed. So if we go through it further, it says on here the plan is to add one, change none, and also one section will be destroyed as well. So if I am happy, let's just do a yes, and it will go on to destroy those that it referred to earlier. Now it will go on to create those that are to be created. Okay, now we can see the apply has been completed. As we can see, apply complete, resource one has been added. Just like we mentioned before, none has been changed, and one has been destroyed as well. And if you recall, we had an output file which its task was to return our public IP address. In this case, here it is. So our EC2 provisioning has been done successfully, which I am happy about. So a quick recap as to what we've done is we provisioned the EC2 instance. We've set up things like the public VPC, subnet, the routing and internet access. We've created an SSH groups as well, and also added some ports to external applications such as Jenkins. We've done the key pair as well, and then part of the task was to create an IAM rule as well for the instance. So the next thing it was meant to do is install Docker, enable Docker as well, and then also Nginx, and the output which we've just seen here, and that's the public IP address. So we can go to our AWS and then see it's live in the flesh, if I can use that term, and hopefully that should be there as well. So I'm in my AWS. If I refresh, let's go to EC2, which is where we are, and I may have some instances running. So if I go through that, and if I refresh this again, there we have it. So here is our EC2 instance, and it's, as you can see, it's up and running. All the key information has been detailed here. So EU Central 1, which is Europe Frankfurt, the IP address which it gave us in the notes. There we go. So that's that there. And then it also gives us things like the launch time as well, which it's moments, literally seconds from my time as at the time of recording. So all of that is done. I'm happy with that. So if we go back to our local machine, I'm sure there would have been additional files that were added to the to the Terraform project folder. So if we go on here, as we can see, as it's going through the configuration and try to provision and create additional documentation tasks, it's added, as you can see, it's added few additional files in here. One that stands out is this one here, the Terraform TF state, and then we also have a Terraform folder. So far, so good. Okay, so now what we can do is you can try and SSH into our EC2 instance from our local machine. So if we what I've done is this: the keeper file, the .pem file, which I downloaded whilst trying to configure the EC2 instance. I stored it in a folder on my local machine. So if I navigate back to the folder where it is, so I stored it into this directory here, DevOps training. So if I do an ls, I should be able to confirm that that file is there. It doesn't. Yes, there it is. So at this stage, what we can do is we can run the SSH command. So that's SSH hyphen I, and then we can put. I've copied the directory where this belongs. So if I paste that in here, for my account EC2, my apologies. So if I do EC2 and hyphen user at IP address, okay, it says on here the authenticity cannot be established. So if we do a yes, okay. Now I believe an error was made in the EC2 user. So if we go back and make this correction, there should be no hyphen in here. Now if we run this again, okay, so that's not accepting it. And if we go through the error here, so operation not supported on the socket. Now if I check my command again, everything seems to be okay. I believe we're missing the file format. So the .pem is the format type, and if we run the command again, hopefully, okay, that has not been accepted as well. So I guess we need to troubleshoot it further. Okay. Let's go to the folder itself. It's a folder structure. We've got our file in here. So if we copy the exact naming of the file, this could prove to be the problem. I'll go back in here again. And then if we then come back and make additional correction, as you can see, we've got the folder roots, but not the file name itself. So if this time around, that should be accepted. Voila, there we go. So our SSH connection has been established. So we are connected to our EC2 instance. And on here we can run a few commands just to begin with. So ls to see what's inside here. It shows that there's nothing in here. I believe Docker should be installed based on our initial Terraform configuration. So if we do Docker -v, which I believe that is to do with the version. If we do that again, Docker, could be wrong. I'll have to check if that's incorrect. So version, that's not liking it as well. And if you do one final try, okay, that's not liking it too. Okay, so it looks like Docker doesn't seem to be installed on our machine, on our instance. This possibly could be due to the fact that the Terraform file, the configuration may not have been right, and that's no problem. What we can do is we can install it manually. So if we begin by clearing everything on our PowerShell at the minute, and then we can start fresh. So there are a few commands on here where we can run to install Docker. So if we begin with sudo yum update and -y, it to finish going through. Okay, so now if we run the next one, that'll be sudo Amazon, I believe it's Linux extras install docker hyphen white, and that doesn't seem to accept it. So if we go through that again, so that is Amazon. That's not accepting it as well. I've identified the error which was presenting itself. This is to do with the Linux version and on my instance here. So if we begin that process again, if we run sudo yum update y, okay, so that's returning there's nothing to do. We can proceed to the next one, which is sudo yum install docker hyphen y. This should install docker. Okay, installation of docker is complete. So we can do is we can start docker. So if we do sudo basically system ctl docker, that should initiate docker. Then we can run our final command as well, which is sudo system ctl enable docker. So that should our docker setup should be complete. So now to verify this, we can run the initial command which failed. So docker hyphen version. And now we can see Docker has been installed successfully. So the next step in the process is to install additional tools on the EC2 instance. So as we've just done, we've installed the Docker, and we can confirm this by doing Docker, I believe, hyphen version. And as you can see on here, we've got a version number as well. So this terminal we're seeing is a local PowerShell terminal, and through SSH connection, we've established a connection with the EC2 instance. So I can communicate with that server directly through my local PowerShell terminal. I've got another PowerShell terminal which is on to our left, and that is the Ubuntu terminal. Now, this Ubuntu terminal is also a local one, and we're going to use this terminal to communicate with a folder I've titled Ansible. So we will use Ansible to install the additional tools on our EC2 instance. Ansible will use the playbook and run our YAML files and pick up any tasks we've set it, and then it will execute it on our EC2 instance. So if we come back into the terminal, what we can do is we can request the list in here, so list of items in this directory. The terminal is pointing at the Ansible directory, and as you can see on here, all the entries have been listed for us. So the one we are particularly interested in is the Jenkins, install Jenkins. So if we run the read command, so we're trying to read that file. So cut into the Jenkins, install jenkins.yaml, and as you can see, inside that file is our set of instructions. What we're wanting it to do in a nutshell is to install Jenkins on our EC2 platform, and then if there's any Java commands in there, it should remove it and then install maybe the latest one, which is Java 17 or one of the most recent ones. It then needs to go ahead and install Jenkins repo and a few other things like the GPG keys and a few other additional items on here, which are all required for Jenkins to run smoothly on our EC2 instance. The correlation between Java and Jenkins is purely because Jenkins is built on a Java platform. So if you're happy with this, I've got a command which we can run, and that should fire off Jenkins, and then the playbook can go and exercise these tasks as I've just mentioned. So if I paste that command in here, we should see that whole process begin. So it's established a connection. It's looked in here and removed any installations of Java on there. And then it will move on to the next task and so on. So hopefully all the tasks within the playbook should be executed as we expect. And then we can go on to the platform and verify that it's worked. Okay, so all looks positive. What we can do is we can go on to our EC2 instance and then check if Jenkins is running. As we can see on here, Jenkins is active and running. So it goes to show that our deployment with Ansible worked. The playbook worked, and it installed all the tasks in there for us. So rather than going on the platform itself and manually installing things, we're able to use Ansible to configure our tasks for us. So what we can do is, given Jenkins is up and running, we can test it on a local browser to see if that is the case. So if we create a new browser, so we can use an existing one here, and what we can do is we can do HTTP and run our IP. And I believe the port for Jenkins should be 8080. And here we go. Jenkins has been installed, and as you can see, we can access it directly. So that has been a success. So I've pasted a password in here, and I will go on to configure Jenkins. So the setup of Jenkins is now complete, as we can see. So at this stage, we've got two routes that we can take. One of them is that we can deploy our code or our application onto Jenkins, and then from here we can sort of build a Docker image out of it, and then deploy it to our EC2. The other option is, since we've got Docker installed locally, we can we've got our image built as well, so we can deploy directly from our local machine onto the EC2 instance. So if we go with the latter option, here I've got a brand new terminal as well as the terminal that's established a connection with the EC2 instance. So going into a brand new local terminal, if we run Docker, so Docker images, and the prerequisite for this command to work is Docker needs to be running in the background. So if I do Docker images, and here is the repository where all the images are sat, and the one we're looking for is the top one, which is a simple Docker app as well. So we can build it, and we can do so by running the following command. So docker build -t, and then the name of our application, which is simple app space and full stop. So this should build our application as well. So we've got a field error, which I believe it's because this has already been built. So what we can do is we can export that file, and I've got a command here which I can paste into the terminal. So this should have exported that file, that image. So if we run another command here, we can confirm that it's created the export. Well, is the exported file in the format is here as well. So the next thing for us to do is to copy this file and load it onto the EC2. So if we run the following command, and an error has been established. So if you go back in here and correct this error, this is to do with the public IP address not being confirmed in here. So if I do 35.159.196.13, that is our IP address. And if we run that command again, it says the connection has been closed. Okay. Again, if we revert back to the command and remove these and try again, hopefully that should be accepted. Okay, so it looks like it's happening. It is copying our application image and loading it onto our EC2 instance. So currently it's going through the percentages. We're nearly halfway and it should be completed any moment from now. Okay, so as you can see, we're 100% uploaded. And if we now come back into our instance, what we can do is we can run the following docker command, which is to load our application. So if you do docker load -i and then the name of our application, which is simple app .tar being the format. So simple app .tar, and we've got a permission denied. So let's look into that further. So if we look on your permission denied, I believe if we add admin, if you run it in admin mode, so if we do sudo and then our command, see it's giving us the necessary permissions to look at it. So here we can see our image has been loaded and it's basically just moments ago, hence it's the latest. Is being shown as well. So our image has been loaded successfully onto our EC2 instance. So the next thing for us to do is to run the image itself. So we can do that by pasting this command here, and we can also see that we didn't get any error back. So this would confirm that it's running successfully with this unique ID. So we can also check this by running a sudo command. So sudo, because we are still trying to run it in administrator mode. So generally we'd run docker ps, but since admin rights are required, if we do sudo, then docker ps as well. And then as you can see on here, moments ago, about a few seconds ago, it started to run the container. So far, so good. So the next thing is for us to test that it's running fine. So what we can do is we can run this command, which should run our application. So if we try to access our public IP address, which we can copy that from okay, and it says the HTTPS is not accepted. So if we go back in there and remove and make the correction, so HTTP, this should be accepted. So it failed to connect, and if it basically failed to connect to the server, so this would insinuate. So I suspect this issue is to do with the port. So what we can do is we can come in here and add that port 80. So if we click on EC2 instance and we navigate to security, we access security groups, and what we can do is we can edit the inbound rules and then ensure that we have port 80 in this. So if you add a rule and set that to 80 and perhaps choose anywhere IP4, that should suffice. So if we save that rule, and it says on here there's an error, so that already exists. So if we revert back, so seeing as that's not the issue, we can remove that line entry simply because it's there and save the rules again. Not made any changes. So if you go back in here, I've run this command here and it's telling us the application is running on port 5000. So if we run the initial command again, which is here we go. So if we type in manually, so docker sudo as we run it in admin mode, so docker run -d -p, and then it's 80, which exists already, and then our port which the application is running on. And then if we do name simple app, which is our application itself, the container, and then the name of our application. So again, we've got a few conflicts, so let's look into this. Okay, so we either remove or rename the existing one that's been in use. So if we do this command here, so sudo docker stop, which is a simple app container, that should hopefully stop it. Okay, now what we can do is we can remove the container entirely. So if we swap the stop for remove, that should be removed. So if we go back and run our initial, here we go. So that has gone through successfully. Okay, so we can now run our initial command again. So if we do HTTP and then our IP address, so if we type it out manually, so 35.159.196.13. Okay, so it doesn't accept it as well. So we can go back and add the curl, which I believe that's the missing piece. And as we can see, that has been accepted. So the next thing for us to do is open a browser. So if we open the browser in here and we access our, which is so 35.159.196.13, and we can see what happens. So if we go back a few steps and then rerun it again, what we can do is we can, lost my screen, we can stop and remove the existing one as we did previously. So if we type this out manually, so again the sudo command, as in we run this in admin mode, so sudo docker stop and then simple app container. this should bring our container to a stop, and then we can go in and run the remove command. Okay, that has completed. So if we then do sudo rm, that should be done as well. So again, if we go back a couple of steps again and run that command, we should see that it is now successful. So what we can do is, again, if we do docker.ps, we can see the status of that, and here we go. Our container has been set up all over again. So at this stage, if we go back to the browser and attempt to rerun our application again, here we go. So hello from EC2, as we originally created our application to do. So far so good. So a quick recap as to what we've done throughout the entire journey. So well, our most recent task is we've built the Docker locally. We've transferred it to our EC2 instance through that SSH connection, and on there we've also gone on to deploy it using Docker, and then we can now reach our public IP address where we can run our application. So our application has been successfully hosted on our EC2 platform. So we can go on and look at a few other things and hopefully learn one or two more. So the next step is to incorporate Kubernetes into our flow. Now, it may not be needed because it's a simple one application. It's not, it's not a number of applications or a large scale application. However, it's good to learn this application as well, to learn this tool as well. So, in a nutshell, if we had many applications, it would help it provide some resilience, offer scalability, and also make it easier to automate. That's where Kubernetes strengths, generally lie. But we can still, like I said, go through Kubernetes and learn more with this. So what I've done is, if you look at the right side of the screen, I've created a YAML file, which I've simply named it simple app deployment .yaml. And if we come back in here, what we see is I've navigated into this directory, and the file which I've just called out is here, and we just basically read in that file. So if we look at the file, what it's trying to do here is it's trying to create new pods where the application can be run, and then also it should create a load balancer and allow the application to be accessible, external devices, shall I say. So that's in a nutshell what the file is trying to achieve once we deploy it. But as part of creating the Amazon ECR registry, so created a Kubernetes service on our EC2 instance. So if we come in here, we will see this has been created, what we call the EKS, and in there are also clusters as well, which have been created. So this is simply a container which the application can be. So clusters, in a nutshell, are just a group of mini systems, basically, that work together to run containerized applications. So if we revert back to PowerShell, for this YAML file to deploy, to run the deployment and also the service in here. So if we run this command, and we get message to say it's unchanged. So what it simply means is that I've run this file previously, and since the last time I've run it, nothing has changed. So all these settings are already configured. So if we move on to the next command, where we can run the pods as well, just to see what comes back. So if we do Kubernetes CTL, get pods, any pods that are up and running. And as we can see, we've got two which are currently running. The next command is to check if the service is running and the load balancer has also been set up. This is so external devices can connect. So if we do kubectl get service, and as you can see, that has also returned fine as well. Our application should now be up and running. And if we paste this endpoint into a browser, we should be able to see that in action. So if you paste that here, but site cannot be reached. So if we remove HTTPS and make it HTTP, okay. So digging into this error further, I've noticed that our application is running on port 5000. However, inside the service YAML file, we are running it on 80. So if we make this change and then apply again, so if we make that change here, save this, we can run the apply command again. Okay, if we run this again, it should now come back to say a change has taken place within the service section. We can then proceed to run and as we can see on here, the application is running. So in summary, in this section, what has taken place is we've created Amazon ECR registry, which is basically a place where we can store the container, which also holds the image to our profile, our application. And then from here, Kubernetes will be able to go in there in this registry, pick it up, and then do various things to it, such as scaling and automate it basically. So we've gone on to create a cluster as well, which was able to run the application. And finally, we configure the application so that external devices can access it through this URL here.